Welcome back to another episode of Earth is Our Home with Dr. Thomas Blaine. Tom is going to be looking at the second part of the 2024 update, so stay tuned. Welcome back to another episode of Earth is Our Home with Dr. Thomas Blaine. Dr. Thomas Blaine is an associate professor with the Ohio State University Extension Program. He's going to be looking at the Global Update 2024. Tom, it's always a pleasure talking with you.
Well, I love doing Earth is Our Home, Patrick. Thanks for having me on. Hope the audience is learning a lot. And we've got a lot to talk about today because we are at the warmest temperature now in the satellite data record. And quite probably we're at the warmest that Earth has been in the past 115,000 years. And temperatures are going up from here, Patrick.
You know, I sort of find it hard to believe that in our 4 billion years as a planet Earth, that last year, 2023, was the hottest in the last 120,000 years or whatever.
Well, it shouldn't be surprising because we talked before about the ice ages. Earth went into an ice age around 100,000 years ago. And there were glaciers throughout what is now the northern United States. In fact, northern Ohio was underneath a mountain of ice a mile thick. Tennessee and Kentucky were like an Arctic tundra. I mean, this went on for like 80,000 years. It's caused by Earth's orbit and changes in Earth's orbit. So when you think about how cold it was for that long, we all know about the Ice Age and the woolly mammoth and the saber-toothed tigers, all those animals that went extinct. It's not that hard to understand that once we started breaking records for this era we're in now, which is called the Holocene, that would put us all the way back to the previous interglacial, which is called the Eemian, that ended about 105,000, 110,000 years ago and peaked at about 115,000 years ago. So it's not that hard to believe when you think about it.
Well, it does make sense. I better understand it. So in this global update part 2, I know that you have gone through why the Earth has been changing, and you indicated that part of that reason was all of the carbon dioxide that we're putting into the air.
Yes, that's the big difference now between, for example, this interglacial and the previous one, as I say, which ended a little over 100,000 years ago. That was not caused by humans at all. And when we went into this interglacial that we're in now, about 15 to 20,000 years ago, that wasn't caused by humans. That was caused by changes in Earth's orbit. But right now, what we're saying is there's a relationship between CO2 and global temperature. It's a hypothesis that we have, that scientists, atmospheric physicists developed in the 1850s, 60s, 70s, and 80s. And so, you know, as we burn fossil fuels, coal, oil, natural gas, things like that, the hypothesis that that's going to warm, it already has warmed the Earth. And we got that hypothesis from those researchers way back then in laboratories where they passed heat through CO2. So now we've got a hypothesis here. And a lot of people don't want to believe this, that CO2, human-induced, is causing temperatures to rise. So that's a hypothesis. Let's look at the data. The recent breakout in global temperatures with the change in the Southern Oscillation was very important methodologically, because the trend in global temperatures had been appearing to ease up before that. In other words, when you went back to 2021, 2022, we were in La Nina and it was holding temperatures down. So the temperatures weren't going up all that rapidly. And, you know, the thing about it is, testing this hypothesis or any hypothesis about global climate is going to be complicated, not just because there are many factors that influence it, but the Earth's climate's a nonlinear system. Now, a nonlinear system is just, it means that if something disturbs the system, the result is not in proportion to its change. So something might seem really small, like a very small change. CO2, a lot of people say, well, it's only 400 and some parts per million, but it's a nonlinear system. If we had no CO2 in the atmosphere, the Earth would be a snowball. We would all be gone, even at 100 parts per million. We have to have the greenhouse effect to stay alive. But as we add CO2, what happens to temperature? It's not an easy relationship to identify because there's chaos in the climate system. And that makes it, a nonlinear system and hard to predict.
As you discuss this in part one, the real question comes down to, so what? Earth has always been able to rebound and to change. So what does this really have to do with our current situation? How will it really affect us?
Great question. So what? Earth is warming. So what? Is that really a bad thing? Well, by the way, we're looking here, the sudden increase came about as a result of that red way out to the right, which is natural. That's the El Nino that we went into early to mid 2023. And you look at that blue prior to that, that was what was keeping temperatures down. This is what CO2 is doing. But again, linking CO2, this increase, with global temperature increase is a hypothesis. And I want to talk about that. And I want to answer your question right now because that was a great question. So let's talk about that. You're asking, so what? Well, Earth's temperature's warmed about 1.4 degrees Celsius, which is 2.5 degrees Fahrenheit in the since the pre-industrial era. That means like 200 years ago, back in the 1820s, let's say. Most of that warming, though, has come in the past 45 years. All right. And there's no way to avoid the 1.5 degrees C because we're already at 1.4. The 1.5 is already baked in the cake because you saw what CO2 was doing. See what that's doing right there? We're not going to be able to turn that around immediately. So the 1.5 degrees C is baked in the cake. And I think there's very little chance we'll avoid the 2 degrees C target. So let's talk about your question, the big question now. If we extrapolate on that trend, business as usual, it would put us at about a 3 degrees Celsius or 5.2 degrees Fahrenheit by late in the century, like 2070 to 2080. Now, remember what I had said before. So far, the warming has been benign. And some global warming activists get angry with me for saying that. We've had warming, but it's been pretty benign. And the best evidence for that, Patrick, when you say, what does it matter? Well, we have to have a decent climate regime on planet Earth to feed 8.5 to 9 billion people, which we're going to have here before mid-century. We're already over 8 billion people. If the climate gets too hot, in areas where we rely for agriculture, corn, soybeans, wheat, and also livestock outdoor grazing and everything. If we continue to warm to something like this by 2070, 2080, remember, it's a nonlinear system. This could trigger a lot of feedbacks and tipping points that would cause a climate disaster, meaning some places will become uninhabitable for humans and uninhabitable for other species. And if they can't move, they'll go extinct. And also a collapse in agriculture at 5.2 degrees Fahrenheit. See, so far we've had 1.4 degree Celsius, which is 2.5 degree Fahrenheit. But if we double that and have a 5 degree Fahrenheit as opposed to the 2.5 degrees, many places, especially in the American South and the Midwest, where we rely on agriculture, they will move into the area of climate disaster. At least, let me say it this way. They will move to a point where climate disaster is a non-trivial probability. Because remember, we're talking about a hypothesis here. Nobody has a crystal ball, including me. It could be possible that these increases in CO2 that we're talking about will not yield this 5.2 degrees Fahrenheit. But I'm saying it's a risk that we're taking. It's a very serious risk. And we're talking about high stakes. So you say, so what? Well, because the stakes are high. Because if we make huge areas of Earth uninhabitable for humans or other species, we're in trouble. And if we have a collapse in agriculture in a lot of places where we currently have productive agriculture, humans just won't have enough resources to produce the food to sustain the population. We have been in this kind of situation before. If you stop and think about it, there are times in human history where it looked like we were in a very serious hardship. And we came up with innovation. Look at the difference between the way we live now and the way our great-great-grandparents lived in the 1800s, when those atmospheric physicists started talking about global warming. They didn't have, electricity. They didn't have, like we do, refrigerators in every home, automobiles, airplanes, central heat, central air. We've used technology here basically to have to configure the Earth to be our Earth. So when you say also Earth was a lot warmer 100 million years ago, that's true. There was no ice or snow on Earth, but there were no humans. That was not our Earth. We can't survive on that because we evolved and developed as hominins over the last 6 million years in an ice house where there's ice on the Earth and snow, different climates that cool the planet down. So there's time to avoid disaster, time to avoid bringing CO2 concentrations to a level that would be expected to cause more than, say, 4 degrees Celsius warming. Because again, 4 degrees, even 3 degrees, very significant probability of climate disaster. And at 4 degrees Celsius, we're talking about a very high likelihood of climate disaster.
I understand your points, and I think your second point, innovation, is key. And I truly believe that we as human beings already know the dangers of high level CO2s. And we have been working, different groups have been working not to necessarily clean the air as it is, how to adapt.
Yes, but what I'm saying when I say 3 to 4 degrees will raise the probability of climate disaster. I'm talking about once the disaster hits, there's no adapting. There's extinction for lots of species and possibly including us. It's hard to kill 9 billion people, but certainly it's something that would bring our modern way of life to an end. I mean, my imagination can't even conceive of what it would be like to live on a post industrial planet where it's been ravaged by a 3 or 4 degree Celsius temperature increase. You know, I mean, alligators and crocodiles would be comfortable in Minnesota with that. You know what I'm saying? We're talking about a temperature change like that. It's just something that it's hard to fathom. It's a probability. Again, it's a hypothesis. The question is, how much risk are we willing to take? Well, listen, we faced these things before. Like I say, 1900, if you were standing on the coast of North Carolina looking out toward Europe, the Atlantic Ocean, heavier than air flight seemed unrealistic. Most of the technologies we have today were not even a dream in 1900. The automobile, the interstates, refrigeration, electricity. We wiped out polio and smallpox. We got the internet. We went to the moon. If in 1900 you said some guys from Ohio going to come down here and fly a machine that's heavier than air, and that's going to start a revolution, and we're going to be on the moon, when the little kids that were running around then in 1900 were senior citizens, they're still going to be alive, and we've got people on the moon, they would think you're crazy.
I think it goes to my point that we are adaptable. We as human beings are aware what our climate is. You know, the average individual, there's more recycling, more environmental awareness. People are doing their best to reclaim some of the wasteful practices that our parents had. And
I'm going to have to just go back right here and tell you this is what it's all about. We can talk about all these things and agreements and how innovative we are. As CO2 concentrations go up, the evidence seems very clear. Again, this is a scientific hypothesis. But as they've gone up, global temperatures have gone up. There are natural things that are influencing temperatures too, like the Southern Oscillation or El Nino and La Nina. I'm with you. We can rely on innovation. The thing about it is, I don't see any technology at this point. I'd be like the person on the beach there in Carolina in 1900. So I don't see any evidence that we're going to be able to get in a machine and fly over to France in a few hours in comfort and eat meals on the plane. I wouldn't have seen that then. And I don't see what innovation can save us now either. I just haven't heard of a realistic scenario for stopping warming or even slowing it down, which is why I don't talk about policy a lot. Like I told you before, somebody will come up with something, hopefully. But, I'm think I teach this well. I've been teaching it for 35 years, but I don't talk about policy a lot or specific technologies. Maybe out there somewhere, yet unborn, is a person or persons that will develop technology that I can't even imagine. So what we need to do is cultivate an environment or a culture that enables these younger generations to do what it takes. And a lot of that's going to mean better education. We need these kids to study math and science, you know. And so here are some readings that I wanted to give you. Jeff Goodell, that's the second one. I mentioned that book last time. You can go to YouTube and type in Goodell, The Heat Will Kill You First, Life and Death on a Scorched Planet. And he goes into, you know, what heat really means for the earth. You know, when you say the so what, that's a really good book. And his lectures on YouTube are also very good, where he goes into detail on why, you know, so what? Well, here's what's at stake, and we're not so far from a disaster. Here's some more reading for you. Some of this is from a while back. The IPCC did its 2022. The fifth National Climate Assessment's recent. Some of these are very recent. Some a little further back. There's my fact sheet. Update 2020. I'll be doing update 2025 next year. And there's what the fact sheet looks like. That's the web address, but you can go to Google or any search engine, type in Thomas Blaine fact sheet climate change, and it'll come up. It's very informative. You can also contact me at this email or phone, and I would love to hear from you. Love to come and address your group. If you would like for me to do that, we can do that by Zoom also now, and I really appreciate it.
I know that there have been a number of innovations that have been occurring, but it seems that there's a lot of information out there that can confuse any of us. Let's take the electric car. During this past winter, we had 1 week in which temperatures really got below zero throughout most of the United States. And it had shown that the electronic vehicles, their energy power was drained quickly. And that's a very difficult situation to hear in a mobile society. The other point is that electric cars are dependent upon electricity. And what generates electricity the most? But gas and fuel, natural gas and coal are the ones that fuel that, which are CO2 kinds of things. So I'm just bringing up that point that we do have those innovations, but are they really helping? I don't know.
Well, we've mentioned before about electricity. We will have to electrify everything. No question about it. Everything's going to have to be electrified. But you're right when you point out that historically, most electric power generation has come from burning fossil fuels. So if you dig up coal out of the ground, ship it to the electric power plant, burn it to boil water, to turn a engine, you know, you're putting CO2 into the atmosphere. You haven't changed anything. You have to find a way to generate electricity. And there are ways to generate electricity without burning fossil fuels. One is hydroelectric. You build the dam, the water flows and turns the turbine. There's hydroelectric throughout much of the United States making electricity. But hydroelectric is not going to be the answer. It's small. It's a very small capacity. But it's that kind of thinking where you realize, okay, how are we going to generate electricity without producing, putting more CO2 into the atmosphere? Because currently it's true, although it's less. I mean, the amount of electric power that's being produced by coal in the United States is falling. It is falling, but it's going to take a lot more than that. That's why I say maybe there's some kids out there right now who will win Nobel Prizes in physics for coming up with innovations that allow us to maintain our living standard without filling the atmosphere with CO2 up over 500 parts per million so that we don't encounter climate catastrophe.
Tom, you have your information on the screen. Can anyone call you or email you and talk about this more in detail?
Yes, anyone can. And again, I would love to come and speak to your group. If you have a group, educational group, civic group, county commissioners, township trustees, elected officials, boards of education, schools, extension is here to take the university to the public. And that's what we do. We take the university to the public. And that's what my job is. We do this with you on Earth is Our Home, but I can also do it to individual groups. And I'd love to. Just get in touch with me.
Hey, we're talking with Dr. Thomas Blaine, Associate Professor with the Ohio State University. There's the contact information. And Tom, thank you.
Thank you, Patrick.